Hello again, Twitch. Thanks for staying with us. We're back for another exciting session here live from the AWS Summit in Sydney. Before we get started, we've got some giveaways to throw out to the people here in the audience.
These
here
are
we go.
totally
Congratulations.
awesome
Thank you.
VMware socks. If you're around, come to the booth. We're giving them out now. Come on, everybody. Who wants free socks?
Free socks. Cool.
Bathroom.
Socks are gone.
All right.
All right.
So this next session, as you can tell, we've got a little bit of a theme going on. We're going to talk about graph databases, and as everyone knows, if you're going to talk about graph databases, you've got to wear a hat, right?
Absolutely.
Yeah.
Absolutely.
So, my name is Gabe Hollenby. I'm a technical evangelist with AWS, and on stage with us, we have some other familiar faces, but we should introduce ourselves in case you're watching for the first time.
My name is Aileen Gemma Smith, AWS Community Hero. I am also the CEO of Visualytics Technology, and we love, believe, and build on graph databases.
We do. I am Matt Fitzgerald, a technical evangelist.
Cool. So Matt, I know you like working with graph databases also. Before we get started, let's talk about a high level. What is a graph database? What are they good for?
Graph databases are good for everything, and that's the right line that I should take when telling people about graph databases. So a graph database is really just a graph.
Yep.
Right.
Right? And when we think about graphs in the mathematical sense, we're talking about vertices.
Now, we're not talking about a chart that goes up and to the right.
We're not talking about a bar chart or anything like that, or line graph.
Yeah.
We're talking about vertices and edges, right? So the very concept of graphs and graphs databases are rooted in that branch of mathematics, which is in graph theory.
Right. But help us understand, because what I've found is a lot of folks who don't come from graph world don't kind of get, well, so what? What exactly am I doing with that? Can you give me an example of how I can start to put information together? Because what you said is absolutely true, but I think that's a little bit hard for some folks in the audience to follow. So can you dig a bit deeper?
I think the first thing is to look at how we use relational databases today, right?
Yeah.
So relational databases are typically used in a transactional kind of manner.
Right.
We have records that describe a transaction. With graph databases, it's all about the relationships amongst things.
Yeah.
Right. The way I like to tell people about it is, in a traditional relational database, the concept of a relation, it's not a first-class citizen. You cannot say to a relational database, tell me about the way all my data is connected.
Right.
That's a construct that lives in our brains, and as operators and coders, we link the data together through foreign keys. Right? The closest thing you have to a relation is like a foreign key. In a graph database, you can say, I have this thing.
Yep.
Tell me everything that's related to this thing in any way.
Right, but that's the power of graphs, right? Because you can start to move and say, give me the context of this event right here.
Yep.
How does it relate to these people here, as well as those folks who are attending, and the larger question of Amazon overall? Like, that's how you start to think about traversing a graph, and it becomes really powerful because you're also not stuck in discrete relationships. You can only look at this thing in this way. So you want to talk more about that?
Yeah. Okay, so I guess first, if we look at where graph databases are used today, so
That's a great idea.
I've been in IT now for 20, almost 30 years, right? I may look young, but I'm actually older than I look. So in that time, I've rarely really come across traditional IT enterprises working with graph databases. So if you look in companies like, well, not so much companies, but the industries of bioinformatics, even mining, social networking, right? So one of our biggest social network graphs is, obviously Facebook, and then you have LinkedIn and all these other cool, like large graph databases. So I think when we start to think about the opportunities for leveraging graph databases, and I'm going to go back and say, I have yet to find any industry or problem domain that could not benefit by leveraging a graph database.
Okay.
Absolutely.
So with that's a good, strong statement. Let's assume that people are now interested. Okay, tell me more.
Yeah.
How do I get started with graph databases? What are the core things that viewers need to know in order to get comfortable with the graph database space?
Okay, so let's first mention our very own graph database, Neptune. Okay, and let's talk about the two types of graph databases we have.
Right.
We have property graphs, or what we call LPGs, or labeled property graphs, and we have semantic graphs. Neptune supports both of those graphs.
Yeah, Amazon Neptune supports both.
Yeah.
Amazon Neptune supports both. So let's quickly go into those individual types of property, property graph and the semantic graph, and we'll look at the various components. And we're getting stuff thrown at us.
It could be a question.
It could be.
It is a question. I think it says, "What's up with the hats, guys?" But it's from Sally Furban. Sally, we like wearing hats. So this hat is an Akubra. It's an iconic Australian brand. I used to live here in Sydney, and now I live in Singapore. And I can't wear this hat in Singapore anymore because it's too warm for the weather there. But I love to wear it when I come back to Oz, especially. Aileen's also a fan of hats.
Absolutely, and let's think about hats in terms of aboutness and graph, right? So we have Gabe. Gabe is a person who's wearing a hat, who's interested in doing more and connecting with the community. Aileen is an entity that is also related to Gabe in terms of we're all evangelizing and championing what's happening with AWS, specifically with Neptune. Then we have Matt, who's also a technical evangelist, borrowing one of Aileen's other hats, because we all want to be very similar, even though we're disparately related. How's that for kind of thinking about navigating through the graph?
Yes, very good. All right, so we're going to bring up a slide. I have a slide that, and we're going to zoom around this and kind of make it a little bit interactive, right? So we're going to start with the property graph. So a property graph is a type of graph database, or type of graph that will resonate a little better with developers, right? So when we talk about property graphs, we're talking about the nodes and vertices being able to have properties that describe them. So we're going to just quickly look at this example here, and I've tried to keep the example the same when we discuss semantic graph as well as the property graphs, because I think it's important to show how these two graphs differ.
Absolutely.
So let's just take a quick look at this. So often, well, before you start any kind of database modeling, whether it's relational or property graph, you need to come up with some kind of schema that you're going to use to model the nodes and then how they interact. So in this case, we have we're modeling a simple transaction, right? So this is probably one of the simplest graphs that you could ever model, right? So we have an account, and it interacts with another account via a transaction. So you'll see here, each one of the accounts has some metadata or properties that describe those nodes, right? Obviously, we need an account ID. We need a balance, maybe.
Sure. If we're talking about like something like a bank account.
Exactly. And then the transaction itself has properties that are intrinsic to that.
Right.
Like
So
the date,
we have
the amount.
Exactly, right? And the transaction is what links, the transaction is the edge that links the two vertices or the two accounts together.
Right.
So what you're seeing here in the sort of top left is really the kind of schema. If you look at maybe the graph in action, you'll see here there's a bunch of accounts that are related. You'll see that the property, we now have values for our properties.
And by related, we just mean they've transacted with each other.
They've transacted, yeah, exactly. And when we're working with property graphs, especially with Neptune, now we have other types of DSLs or domain-specific languages for working with property graphs, but the one that is familiar to probably majority of people is Gremlin.
Yeah, it's a graph traversal language, open source.
Open source. So Neptune Neptune has a Gremlin endpoint, and you can submit Gremlin
traversal
queries directly to the endpoint, right? And so if you're, and you can see how this would resonate with developers a little more to say a SPARQL query, which we'll see a little bit later on. But we're just going to zoom in a little bit here and take a look at a typical Gremlin type statement. So G is our graph, add V, whoa, we're adding a vertex, right? And then you'll see we just chain our properties at the end of our vertex statement.
So it's very much like a Fluent or a Builder style interface here.
Yeah. So in this case, we're adding two vertices, and then we need to add the transaction to join the two, the edge, right? So, and obviously that's the add E, right? That's the edge. And so Gremlin actually supports, you mentioned traversals, Gabe, but you can also operate directly on the graph. So you can call add edge or add vertex as well. So, but in this case, this example is showing the traversal syntax. So that's pretty much how you, at a very simplistic level, how you actually work with property graphs with Neptune and Gremlin.
It feels very similar to how if we were to draw our problem domain on a whiteboard, we would probably say, right, I've got accounts, I link them by an event, a transaction, right? Like the verbs and the nouns. But there's another style of working with graphs, like you mentioned before, from the semantic web space. Do you want to talk about that?
Yeah, so this is where things, so semantic Semantic graphs are a little bit harder to get your head around because they start off, the primitives that we are typically working with are what we call triples.
Right.
Right, and a semantic graph database, a subset of it could be the triple store.
Right.
But the semantic piece of it is determined by the axioms or the rules that we apply to these triples.
So back up a second for folks who aren't in graph world. What's a triple? Can you walk us through that?
Yeah, so a triple, we talk about triples in terms of subject, predicate, and object.
Okay.
So basically,
and this comes out of RDF, right?
Right.
The Resource Description Framework.
Yep.
It's sort of the open standard from the semantic web.
Yep.
Most of you might be familiar with like a V card, right? That's a very common example of something from the semantic web. It's an RDF strongly typed schema that says, right, if we want to express my name and my address and my phone number, this is what this schema should look like.
Yep.
And the idea is with enough RDF schemas out there, we know that we can interchange data in a dependable format.
Yep.
Yes, correct. So if we look at the schema of a semantic graph, like we're still looking at transactions here, and transactions between accounts. But you'll notice now that transaction is actually a node in the graph alongside account. Right.
So this looks very different to the other one.
Yeah, it's very different because we're only dealing with triples,
Right.
subject, predicate, object.
Right.
Right. So our properties now are either a data property, which could be some literal, like a number, or you have an object property, which is another object, another identifiable object within the graph in the triple store. And just a sort of a fun fact, you might also hear the term quad store thrown around as well. So the quad, the fourth thing is typically the graph or the context that you're working in.
Okay.
So it allows you to have multiple contexts that you can switch between. So if you look at this one, this is kind of interesting. So we have our two, I guess, vertex types, our node types. We've got transaction and account. Then we have these properties that join them all together. So where you see a node or vertex talking to another node or vertex, they're the object properties, right? And where you see these little yellow boxes, these are data properties.
Right.
And these data properties, you'll see that we have types here. We have strings and floats, just like traditional relational database. A triple store or a semantic graph database doesn't really apply any kind of constraints to it, right? We go back to the semantics, right? So the semantics or the ontology, which is a collection of those rules that will define. And this is, we can really go to town here. We don't really have a lot of time at all, but we have these things called reasoners, and a reasoner takes the ontology or the axioms in the ontology and applies it to the triples.
Can you get, so this is all very sort of highfalutin thought space stuff. Can you get real in terms of, without even looking at code for a minute, give the viewers a concrete example of this in action? Like, how is this actually valuable and not just cool math stuff?
Okay, so forensics intelligence community, right?
Okay.
So let's say I'm looking at people of interest, and I want to identify relationships. Oh, and we've flipped across the chime. We'll get out of that. We'll go back to here. And I want to identify people of interest and how they may interact with other people. Because there may be other people we don't know about yet who are also involved in shady activities.
Sure.
Right. So we can't, if we don't know about that relationship, we can't model it, right? But we could infer it by the way the shady individual interacts with the things around it. And they could be other individuals, but they could be interacting with a building. You may identify two individuals leveraging the same building, right? So there's it could be a really bad inference, but we could say, well, this shady character went into this building, this other person went into this building, we're going to make an assumption that this guy's shady as well.
Or maybe not, that may be going too far, right?
Maybe.
We could at least identify it as something worth more investigation.
Exactly. Yes.
Okay.
So that is the inferred nature, and that is the job of the reasoner.
Right.
And there are many different reasoning algorithms out there, depending on the domain that you're looking at.
Absolutely. And if I may,
Please.
let's think about another real world example. And this is something that we did a few years back.
We being you at Visualytics.
We being us at Visualytics. So we all came from kind of graph world. We actually started at a semantic news engine a long time back, and then we reformatted and became Visualytics. So I want to talk about graphs, and I want you to think about rats.
Mm-hmm.
So,
Rats, like
you know, the
rodents.
scrubby, like,
Okay, yeah.
that. Okay, so imagine, here we have a city. A city has a grid. Those grids are buildings. Those buildings have stores.
Yep.
Gabe, you are the store owner who has a wonderful eatery. You've got amazing lunches, etc.
It's a bakery.
It's a bakery.
Yes.
All right, we got Gabe's Bakery. Matt, on the other hand, he's a fine jeweler. He sells diamonds, sapphires, you name it.
Okay.
He's got it. All right. Then you got your little creature here. He's scurrying down the street. Somebody calls in and files a report with the city saying, hey, there's a rat. I have to contextually know that Matt isn't too interested because the rats probably aren't going to make off with the diamonds. I don't know.
They're not probably interested in even going near his store.
Right.
Even if it's next to mine, they
But-
want the bread.
But in terms of Gabe's store, they're going to come by, they're
Yep.
going to keep bothering you.
Yep.
So that context of what you do, how does this event of that rat report impact you? That's kind of what the power of graph does. And as we start to think about more things like, hey, they're doing construction, and guess what? Sorry, they stirred up the roach's nest. And
Right.
now, yeah, you got other kind of scary creatures. It's those impacts an event. How long does that matter for your store? A couple of days. How long does that matter for your store, even though geometrically you're pretty close? Does not matter. When it does start to matter is then when the city comes with the big exterminator and puts stuff in front, and now all of your customers who are about to buy diamonds are like, you know what? Bad sentiment right here.
Yeah.
That's the kind of idea that you can dynamically move across multiple different kinds of relationships and point out things. So absolutely, there are so many different examples where it can be possible.
Yep.
And what I just also want to kind of throw in there, sorry that my mic is a little bit crooked, but hopefully the sound is okay, is understand how dynamic these graphs are, that we can continue to extend them, we can continue to do things. So when you start to get on order of we've got billions and billions of triple stores, is it performant, can I still afford it? The answer to both is yes. And this is why products like Neptune can be transformational for companies once you open your eyes and say, hold on a sec, that guy Matt gave a really cool talk about graphs. Let me think about what else we've got here.
Yeah, absolutely, totally. But we have a lot more time. Well,
Yes.
a little bit more
A
time.
little bit more time.
So I do want to just have a
You want to show an example of the others?
Yeah, show the
query
viewers
language?
of. So before we sort of looked at a Gremlin traversal that showed how to put some data into a property graph.
Yeah.
Yep.
Because I want to show you how you query with Gremlin, and then I'm
Okay.
going to show the flip side of that, which is the Sparkle side of things for
Okay.
Semantic Graph. So once again, very familiar to developers. So if you're familiar with trees and dictionaries and stuff, obviously, you know, that key value store kind of thing, it's very easy to work with Gremlin. So once again, we take our graph and we go through our list of vertices where an account ID equals something,
Yep.
Some string.
and then we're just
Yeah,
basically
what is this
showing.
out? Why
Yeah.
does it say out there? Are you taking out a property? What's going on there?
Yeah, so we're actually looking for anything that has an outbound transaction.
Ah, okay.
Yes.
And so instead of out, you could say in there if you wanted to instead.
If you wanted to see what was coming into it. Yeah.
Okay, right. So it's important to say that at least if you're working with a property graph model, these relationships have directionality.
Yeah.
Correct.
It's a directed graph.
And I would say almost any graph that you're using in traditional graph database has some kind of directionality involved in
Okay.
it.
Yeah.
Like because even in semantic graph when we don't typically say a property, an object property or a data property can come back on itself. We have this concept of symmetrical properties but it still is a separate direction, right?
Yeah.
It's like having two lines, one going out and one coming in.
Yeah.
Okay.
So if you were to run that, you would see that it would be operating on these two accounts here because these are the properties that match our query up above. Now, if you look at the Sparkle side, so actually I'm just going to quickly go back to...
Sparkle's a lot of fun.
Yeah, we didn't focus on how to get the transactions in.
Into the RDF side of
yeah,
things,
into
if we
the RDF side of things. So we have RDF XML, but there are other formats we can work with as well, like Turtle.
Yep.
But when you're typically working with semantic graph, you're taking the data from some other place. and then you're constructing your triples, and then you're bulk loading them.
What do you mean by some other place?
So it could be a transactional system from a traditional relational system,
Yep.
because you may have multiple operational systems that have collecting data, but you talked about it right at the start. It's very difficult to make these connections when they're in these different databases. And even if they were in the same one, you have this convoluted
It's
joins
really
and
heavy and complex.
Yeah. So we created a bunch of triples and we load them in. And then we can apply our semantics, our rules, our axioms on top of that. So this is just an example of what these triples may look like in RDF XML.
And it looks pretty verbose, but a lot of that is just due to the fact that XML, by its nature, with all the name spacing, is verbose, right?
But the name spacing is also intrinsic to the semantic graphs as well, because we have IRIs and various things that identify. So namespace is a core when we're going to be federating data sets, right? Yes.
What does that mean? What does federating a data set mean?
That's the word we're all like, wait.
Federating data sets. So, for example, I may have a database, a graph database of people, right?
Okay.
And so there is an ontology. There's a namespace prefix called FOAF, F-O-A-F, friends of friends.
Yep.
So that may not necessarily be the database, but it could be the ontology that describes those things, right? So the FOAF ontology and the triples associated with it could be a completely separate graph database to say the buildings that we talked about earlier on, right?
Yep.
So I need a way to uniquely identify my people and uniquely identify my buildings.
Right.
And buildings could have the same names as people. We don't know. So namespaces allow us to compartmentalize this data. And compartmentalizing data and having these really unique identifiers and namespaces also allows us to federate them, because we can mix and match and import different namespaces into our Sparkle queries to work with.
So you could sort of think of the namespace as like a dependable, it's two things. It's a dependable schema, because you know what you're talking about, and it describes a unchanging foreign key place, right? It's data from some other place that's always going to look in a certain way.
Right.
Correct.
Okay.
Correct. So for our example, we're not really working with namespaces because there's no need, right? They're it's a very simple ontology. So we don't really have any namespaces here, and I don't want to muddy the waters in terms of what the query. So
this is about the possible.
This is about the possible. So we're going to.
All right.
We've got some giveaways here.
We're giveaways. We're interrupting our graph discussion with giveaways. What
all right, you guys, come here, ladies and gentlemen, giveaways. Who wants some lovely socks?
As you're
while
getting
Gabe's throwing stuff away.
Let's get back to the graph, because this is what's really important for folks to understand.
So this is a Sparkle query.
Right.
Looks a little bit like a standard structured query language query.
Yeah.
It's not really. You'll notice that we have these things called sends, receipts. We talked about subject, predicate, object.
Right.
Right. So.
Subject, object, predicate. Yep.
This is a very distracting audience we have here.
Right, so this is the context of distraction as you're building through, talk us through.
Yeah, so if we look,
predicate, object,
so let's just take the select away, right?
Yep.
Select is showing we want to get something out of the database.
Right.
And in this case, you'll notice that we have all of these words or these terms that have a question mark in front of them.
Yep.
Now these are like variables or some sort of placeholder, okay?
Yep.
And account ID, what is that? I don't know, it doesn't matter. But if we execute what's in the braces, we'll say that we want some placeholder.
Right.
What's this sends, right? Subject, predicate, object. So sends is the predicate here.
Yep.
And if we look at our graph, we'll see that our sends is this. So what is it saying?
It's just doing pattern matching.
Something sends to trans,
Yep.
right? So we know straight away that the scope of the query is going to be working with accounts that are related to transactions via the sends predicate.
Well, actually,
it doesn't. Those are your subject and object, and the sends is your predicate.
It seems to me, though, that it doesn't even say it must be an account. It just says, find me anything that sends to anything. And that's the power of the graph.
Yes.
You're talking about the relationship.
You can restrict it.
Right.
So I can put in a type where it sends to a type of something.
Right.
But in this case, it's just saying find something that sends.
Yep.
Right. And then we receives. Same thing. I'm looking at this one. So now this is the scope of my query.
Yep.
So that just goes and gets any account that transacts with any account. But then we want to put some constraints on it. So then we say, okay, where the trans, which was this one, the transaction, has an account ID, transaction ID of 12, and where the destination
So it just keeps laying on those filters.
yeah,
Yeah.
but
Yep.
where the destination account ID is unknown, we're going to pull that from the graph.
Yep.
Right.
And then this is what we're going to extract out and present back to the user.
Okay.
Yep.
That makes sense.
So I think we don't have a lot of time left, but I just want to briefly touch on ontology-oriented development.
Sure.
So this is where we can use the Gremlin-style syntax on top of semantic graphs. So there's only really one open source tool that allows us to do this, which is Already, which is a Python library. But you'll see here, this is the same way. We're doing the same thing
Right.
that we were kind of doing with the Gremlin,
Yeah.
with creating a new account. And you'll see it's very object-oriented looking, right? We just call it
It looks very
ontology-oriented.
declarative.
Yeah.
It is. New account. We put in the values of the properties, the data properties, and then, and we can create all of the transactions and all of the other bits and pieces that are hanging off that account directly
Cool.
in the code.
And
All
we
right.
can do all of this on Neptune.
Yes, so
You
it's
can do it all
important
on
to
Neptune.
Yep,
Yeah.
we've got to wrap up. Oh,
Yep.
we've got one more question, but we have to wrap up. So we will try and take your question offline in the chat.
Yes.
Thank you so much for sending the questions to us. Appreciate
Take care,
it.
everybody.
Stay
Thank you.
with us. We're going to come back to you with more topics right after this.
Thanks.
Thanks.